This problem is to find the volume of a hemisphere by rotation. A circular disk with radius capital R lies in the upper half of the xy plane and is centered at the origin. Consider the upper half of the circle described by the equation x equals the square root of capital R squared minus y squared, where y ranges from 0 to capital R. Find a volume of the solid formed when this semicircular region is rotated around the y-axis. First step is to understand the region. We are working with the right half of the upper semicircle. The curve given is x equals the square root of capital R squared minus y squared. This describes the right side of a circle, where x is positive. The region is bounded between x equals 0 in this curve for values of y going from 0 up to capital R. Next step is to visualize the rotation. When this region is rotated around the y-axis, each horizontal slice at a height, y traces out a circular disk. Since the region starts from x equals 0 and extends to the curve, the radius of the disk at height, y, is the square root of capital R squared minus y squared. That means we are dealing with a solid disk. No hole in the middle. Next step is to area of the cross-section. The area of each circular cross-section is pi times the radius squared. Since the radius is the square root of capital R squared minus y squared, squaring it gives capital R squared minus y squared. So, the area of the slice is pi times capital R squared minus y squared. Next step is to set up the volume integral to find the total volume. We integrate this area from y equals 0 to y equals capital R. That gives us the integral of pi times capital R squared minus y squared, with respect to y, from 0 to capital R. Next step is to compute the integral. We now compute the result of that integral. The integral of capital R squared with respect to y is capital R squared times y. The integral of y squared with respect to y is 1/3 y cubed. So evaluating the expression at capital R gives capital R cubed minus 1/3 of capital R cubed. That simplifies to 2/3 of capital R cubed. Multiply that by pi, and you get pi times 2/3 capital R cubed. Next step is to account for the full region. Remember, this was just the right half of the semicircle. To get the volume from rotating the entire upper semicircle, we double that result. So we multiply pi times 2/3 capital R cubed by 2, giving the final answer, 4/3 times pi times capital R cubed. When rotating symmetric regions like semicircles, always notice whether you're integrating the full shape or just half. Use symmetry to double your result if needed. That's it for this question. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.